Hello.
Here we are, all smiling, except for Ryan. Ryan, now you're smiling.
I'm smiling. Why? Maybe I wasn't in the countdown.
The countdown, you were like this. I was like, so we're here today, back to do a really good video. We waited for Ryan to do this one because Ryan is the self-declared measurement king.
What do you have to say about that, Ryan?
I self-declared.
Yeah, I mean, means you declared it yourself.
I don't remember declaring that. Yeah.
Now, today we're going to be talking about speaker measurements, but we're going to be talking about how you would measure speakers, subwoofers, tweeters, mid-ranges, if you're going to be doing a two-way, if you're going to be doing a three-way, if you're going to measure a speaker that's already designed and built. It really doesn't matter. We're going to be talking about different ways to take those measurements, some of the things to look out for, things not to do, and some of the things that you should do that would help get you more accurate measurements that will help you in the long run with either speaker design or just taking measurements of already completed speakers.
Very cool.
Does that sound about right?
I'll be right back. 10 seconds. I just got to do something. Sorry, I should have done this before. I'm a jerk.
Yeah, he left us last week, and now he's like, oh, yeah, we'll see if Ryan comes back.
He's going out for a pack of smokes. All right. Someone says there's only one answer, the Klippel near-field scanner.
I'm
going to disagree, but I do want one.
I'm going to disagree with that, too, but we will talk about that. Clobber Cow 1 says there's only one answer, which is the Klippel, which is the near field scanner. What do you think about that, Brian? We can't hear a word you're saying. You muted us.
I'm not the self-declared expert.
We know you're not. We're just kidding. But what do you think when he said Clobber Cow says Klippel's the only way?
Well, I disagree. I think it's a great way, but I don't think it's the only way. There's limitations to what people have. I would assume Clobber Cow doesn't have one. Oh. I didn't know that. I didn't know that. I'm sorry. But that makes sense. But we can explore that. I mean, the Klippel is an amazing tool. But
we're all seriously going on about how you can go the Klippel route, and he's like, I'm being sarcastic. We're like, oh yeah, well, good. Yeah, because I mean, the truth of the matter is, not most people don't have access to a Klippel. Most people can afford a really inexpensive USB mic. Most people can afford a DATS V3. And when we're talking about measurements, guys, we're not just talking about frequency response measurements. We're talking about also impedance measurements and other things. And we'll talk a little bit about why the DATS is good for things other than just impedance measurements, because there's other things that you can measure with that. Now, while I'm saying that, if you guys want to buy anything that we're talking about, check our links in the description. There's some affiliate links down there. It does help out each one of our channels. And I think at Parts Express, I still have a coupon that I think works. It saves you a little bit of money as well. All right. So if we're talking about measurements, we're talking about measuring an already pre-built speaker. So one's already built. What are some of the pitfalls you think you should keep an eye out for?
In a pre-built speaker?
Yeah. So if someone's like, let's say that the speaker's already built, the crossover's already designed, and someone says, I want to take some measurements. What are some of the things that you think that they should do and shouldn't do when measuring that speaker?
First thing that comes to mind, because I'm going to admit that I made this mistake really early on. You want to know where the reference axis is on that speaker before you measure it. A rookie mistake is
great point.
A rookie mistake is to just set a mic out in front of it somewhere, because you see so many photos of people measuring speakers. You're not certain exactly that the mic placement is super important. You want to figure out where the person that designed that speaker, said the reference axis was, because if you're trying to replicate their factory measurement or any third-party measurements you've seen, it's going to be on that reference axis, or it should be.
Mm-hmm. Yeah, that's a great point. I think Aaron got in trouble once because, Aaron's Audio Corner, I mean, not in trouble. I think the manufacturer reached out to him and said, actually, you're not measuring at what we would consider the acoustic center. So typically the acoustic center of a speaker, when we're talking about like that reference measurement, we're talking about where should we start our on-axis measurement from. Typically, if not said otherwise, it should be the center of the tweeter. Okay, so wherever the tweeter is, that's typically where it is. However, some speaker manufacturers will say, actually, where we've designed our timing is in between the drivers, or
Yeah.
you can see some drivers that sometimes they have the mid range and then the tweeter below, and sometimes they've used the mid range, the center of the mid range. So you want to take a look at where that reference axis is. That's definitely a good idea.
Yeah.
I think that's true. I mean, it helps to know off the bat, but if you take a complete set of measurements, which if you're taking a frequency response, I think you can do this, then oh yeah, Clobber Cow's kind of on it.
Mhm.
In the vertical direction and potentially the horizontal direction, depending on how the speaker is laid out, but in the vertical direction, if you take all your measurements, you will see a lobe. And that forward lobe should tell you where that listening axis is.
Mhm.
So you should have a big null. Usually for most speaker combinations, it'll be like 30 degrees above and below the listening axis, and then a big lobe. And at the peak of that lobe, you'll have the most sound power. And generally that's where you're supposed to listen to that thing. And that's generally on the tweeter axis. Or yeah. So although I agree with you, Cameron, it's helpful to know. I think you can kind of determine that pretty quickly if you know what you're doing. If you're just taking some measurements and then you're going to post them online and say, hey, is this speaker okay? Then maybe you're not going to find that very easily. But someone who kind of has a handle on measurements should be able to find that pretty quickly.
Yeah. Yeah. I
Now,
agree.
another thing that we talk about a lot is reducing reflections when you're doing speaker measurements. And we can do this a couple different ways. You can do this by bringing it outside, lifting it up real high off the ground, and try to reduce those reflections. Another thing is a lot of people will put these on speaker stands and things of that nature. You know, the speaker really should be hanging over the edge just a little bit. I've seen a lot of times where people have put them like on countertops and put the speaker behind, like sitting on the counter, where there's a reflection point right there, the counter itself, which can obviously the waves can then hit that and then create some deconstructive waves during your measurements as well. So, you know, placing the speaker is a good point to talk about. Like when you're taking that measurement, make sure that you're placing it in a way that you're measuring just that speaker, or at least as much of just that speaker as you can.
Yeah. That's a really good
Yeah,
point.
I think that's the easiest mistake for a beginner, and the most important thing. Doesn't matter if you're a beginner or advanced, you got to get rid of those reflections, assuming we don't want to know anything about the room and we want to know about the speaker. Which generally, when we're talking about measuring a speaker, we don't care about the room. We want to know about the speaker.
Yeah.
So, for most of us who are limited by our homes, if possible, I try to get it outside or in a garage or shop with a high ceiling. Some place, you know, if you have like an atrium type room or something in your living room, anywhere that the ceiling is often the limitation. So
That's pretty normal. Most people have an
Yeah.
atrium in
I
their
bring
house.
it out
Yeah,
I bring them all out
yeah,
to my foyer, my 30.
yeah.
Hey, some
I'm just,
houses are nice, you
I'm
know?
kidding. I'm kidding. I'm kidding.
Like,
One can dream.
hey guys, come out to my atrium. We'll go ahead and test my speaker out.
Chives, bring the speakers in. We're going to measure them.
I have my garage has a really low ceiling in my new house. I had a shop with a like 12-foot ceiling, and so I could get away with a lot of measurements in there, but my new house, I have nowhere really to do it good. So I have to go outside.
Yeah, and there we've talked about this before. You know, I'm a big fan of the Omni mic. Clobber Cow brought up the Omni mic. The Omni mic does have a way that helps, and it does a really good job. I've measured them outside and I've measured them inside, and most of the time it does a really good job getting rid of reflections. And it's called a blended mode. And if you use the blended mode, it's actually pretty impressive what it does. Now, is it going to be perfect? No, nothing's going to be perfect. We'll talk a little bit more about how to do measurements, low end measurements, in a little bit. But before we do that, let's talk about what Clobber Cow says. He said the one thing that caught my eye is Dayton's new microphone. That's their new Omni mic. I do have one of these in for review. I haven't done it yet. We're working on the background about maybe doing another feature. And if that feature can be implemented, I want to make sure to tell you about it. If that can't be, then, you know, I'll tell you about that too. But otherwise, Right now, we're still working on something, but it can do timing via light, and that's exactly right. We had this conversation with someone because someone was saying that let's explain how the OmniMic works first. Actually, the OmniMic works like this. There's a microphone, like a normal microphone, and it has a little IR sensor on the top of it. Now that senses an IR signal. Now you put an IR box on top of the speaker, okay, in line in the center, in line with the microphone, and it shoots a light to the microphone, which then determines the time difference that you have between the different drivers that are being made. Now, this would obviously be for someone that's designing their own speaker. The biggest issue when designing a speaker is figuring out the timing difference between, say, like a tweeter and a mid-range. And that's because the sound is going to come out at a different time between each of the drivers. And so we need to figure out what that is so we can account for it. Now, the way that the OmniMic is now doing that is they're using the speed of light. Now, we had someone argue with us on the channel that that's not good enough. Me and Ryan, we've talked about this a lot. Now, why would the speed of light be fine with measuring? Their thought was that the point source of where that light needed to be the exact center of each one of the drivers, and we say no to that. And Ryan's really good at explaining this, so I'll let him do it.
Okay. Well, basically, the speed of light is so fast that it's inconsequential to the whole system. But the other thing is, it's going to be the same every time. So that signal is going to be sent out from the computer. It's going to go to the device, the light, and it's going to go. So even if you were concerned about the speed of light, it's going to be the same every time. Whereas for the speaker, the speed of sound is the same every time as well, but it's going to leave the cone or dome or whatever transducer you're using. It's going to leave that device at a different time.
You have to have a reference point.
Then the other transducer, yeah, like if your reference point is your baffle, okay, and you put your little light there at the baffle, it's going to go to the mic the same every time, and it's going to tell the microphone when to start counting. The drivers or transducers, they're going to send their signal out slower, of course, because it's speed of sound instead of speed of light, and at different times. And it's going to be able to count the difference in time. And so if you know the difference in time, you now know your acoustic offset. And it's hopefully that simple, if that made sense.
Yeah, exactly. The basic premise is the speed of light is significantly faster than the speed of sound, which is why we can use the speed of light to determine the distance of the sound. And you're right. And as long as it's in line, you're good. If it's somewhere way off. Now I asked Dayton, I said, why did you do it that way? Because there are other ways to do it, like a loop feedback method, right? We could do a loop feedback method, and some people want to do that. And I said, why did you do the speed of light versus the loop feedback? And they said, because if you're measuring this for, like, say, home theater, and you want to be really far away, or in your room and you want to be really far away at your listening position, well, now you don't have any cords to have to worry about. You just have the light source. And I said, that's actually I didn't think of it like that, but that was a really good point.
That's kind of true, but Clobbercow's pointing it out, and he's right. You could actually put that light right next to the sensor. I don't know if the sensor's on the microphone or where it is. It doesn't have to. It could really be anywhere. It's just a signal to tell the computer to start counting.
Right.
So, I mean, yeah, you
want it somewhere in line.
I guess Dayton's right that you're eliminating a cord or whatever, because that thing could be at the speaker, it could be anywhere. You just got to tell it, it's time to go. I think OmniMic 1 used a chirp, if I'm not mistaken, which has been used in systems prior to OmniMic. That's not a new thing. And you put the chirp close to the microphone so it hears it first, and it's always the same. And then the transducers emit their sound and arrive later. But it's that difference in time that matters. That's all we care about.
The relative offset, yeah.
Yeah.
So while we're talking about this, we should mention how you would set up if you're doing a multi-driver system. So let's assume a two-way first. So if you're doing a two-way system and you're like, how do I start with my measurements? There's two measurements you need to take. frequency response, and you need your impedance. You need those two. Now, for frequency response, we usually do 3 measurements if you don't have the new Omni mic. So what you're going to do is you're going to take your microphone and you're going to put it at your reference access, which we already mentioned is typically going to be tweeter level. You're going to put that, take it off the ground, take it off your cabinet, put it somewhere, hopefully midway through the room if you can. So like halfway up through the room. Speaker stand is what most people put them on. And then you're going to take your microphone, and a lot of people say, put it 3 feet back. I don't personally do 3 feet back unless there's a law of drivers, which we can talk about a little bit later. But typically, if there's only 2 drivers, 18 inches, 16 inches is good enough. You want to cut down on the reflections of your room. So you don't want it to be too far into your room where all of a sudden you're creating more of measuring your room. So you want it to be a little bit closer if you can. And typically 16 to 18 inches is going to be more than enough for something like that. And then your measurement.
I don't disagree, but I would only do that with a small speaker.
Well, that's what I'm talking about. The little 2-way.
Yeah. Okay.
Go ahead.
Even kind of a big 2-way. Like I work with a lot of waveguides and stuff like that. So I guess, then I'd be looking at 3-4 feet. And it doesn't have to be exactly a meter, guys. That's just a power calculation thing that people. Yeah. It could be any distance, really. But yes, the closer you are, the less reflections you'll get.
Cutting out as much of the room as possible.
I should reword that. You get the same amount of reflections, because somebody's going to go, well, actually, you get the same amount of reflections. Just the distance between the speaker and your microphone is shorter relative to the distance of sound traveling to the reflection and back to the microphone.
So we're getting a little too complicated, probably for a lot of people.
Hey,
remember, we're teaching basics. We're teaching basics here. No, I'm just kidding. So then we're going to take 3 measurements. We're going to take one of the tweeter without moving the microphone, the speaker,
or the volume knob.
Or the volume knob. Take one of the tweeter, one of the mid-range, and then you're going to take one with the tweeter in mid-range wired together in parallel. So that means positive to positive, negative to negative. And that last one is really important. Why is it important, Cameron?
Ooh, that's our Z offset. That's as we were just talking about with the new Omni mic, giving us that information. The relative offset between our speakers is what we're going to use later on in crossover design. We're going to take the parallel measurement of our tweeter and our woofer, your mid-range. This can be done for a 3-way too. This can be done for as many drivers as you need. It gets a little more complicated. I don't know if you want to get into that, but the methodology.
Well, let's start with the 2-way first.
Yeah, the method's the same here. The idea is the same anyway. So we'll measure our drivers in parallel. When we go to put those into our simulation, we know that when we introduce parts into the signal path, they create a phase shift. So we need to tell the software the difference between the distance of our drivers and what the time arrival of those is, so that when we go to build our crossover, we're in phase at the crossover point, and that we don't wind up with issues later on. If we didn't have that information, it'd be a much bigger problem. And this is kind of connects over to the part about pre-assembled crossovers and all the issues involved there, why we can't just use off-the-shelf calculations for crossovers. Did I miss anything?
Unless you want to physically time line. So I don't know.
You could
listening to you.
you could physically time align your drivers. That's definitely a possibility.
The only thing I would add to that is I haven't tried it, but I believe you could do them in series if anybody's worried about low impedance on their amplifier. I think you can do it in series. The big thing is when you put it all into your simulation software, you just would have to tell the simulation software that this measurement is for these 2 drivers wired in series.
Yeah.
So I used to do this all the time, and I'd use Jeff Bagby's software, which was a Microsoft Excel spreadsheet. I think it was Excel. It wasn't Word.
We must have all started that way.
Yeah. Well, actually, I did it for many years, and I had to keep getting work. In fact, when I started the channel, I was still doing it that way. It wasn't until I saw your video on how to implement, because I didn't know XSIM had that you can add a graph overlay, which actually makes it much easier. So if you haven't seen that, both Impulse Audio and I have done a video on XSIM now on how to utilize that in XSIM. Still my favorite, probably, to just design a crossover because it's just very simplistic. I don't need all that other stuff when I'm designing a crossover, although some people like the other things. For me, I'd rather just get doing the crossover. But having said that, there is where you can go into and add a graph overlay. And what you do is you add that graph overlay and you go into your driver and you set the delay. So for example, the tweeter, we know, is going to arrive typically faster than the woofer. Why do we know that? And that's because if we take a look at the magnet structure of the tweeter, the magnet is much closer. So where the sound is centered and outputted at is going to be closer to the front baffle, where the mid-range or woofer is going to sit back much further. So we had like the tweeter starting here and then the woofer starting here. And so we need to figure out what that distance is. And it would be great if we could just take a tape measure and measure it, but that's unfortunately not how it works. So we use that third measurement to be able to calculate the difference. And then we put that into our software. If you don't put that into your software, what will happen is exactly what Cameron said. You'll go ahead and design a crossover around the first two measurements you took, but your phasing will be wrong. And when you actually start playing the final result, you'll notice that where that crossover point is, you're going to have a lot of issues.
Yeah.
One thing I'll add to this discussion, which is maybe a little bit higher level, but if you're using active crossovers, you can kind of, I mean, I wouldn't skip this step, but you can kind of flub it a little bit and not worry about it so much. Don't skip the step, do it, find out your acoustic centers. But when you're all said and done and you have the drivers kind of working the way you like, you can just dial in delay. And that lobe I was talking about on the vertical axis, that's basically your listening axis. And with delay, you can basically just steer that thing up and down however you like, down to the 0.1 millisecond or whatever your DSP will allow. And you can just steer that thing however you like. So even if you screw up figuring out your acoustic offset, you just dial in delay till it's perfect using measurements after the fact, and you can do a really nice job of that. So that's just something to think about.
I like that you brought that up because I actually did both methods. So I did a traditional relative offset measurement with a parallel measurement, and figured out my delay and then added that into the DSP software sometime recently. But I also experimented with exactly what you've said, Ryan, and you're able to watch something like OmniMic takes live sweeps. So it just takes measurement after measurement. It's essentially constantly measuring. And so you're able to adjust things and see the result in real time versus something like Rue where you're waiting for the long sine sweep and you check it. OmniMic, you can sit there and play with your measurement and slide the delay until you get that really good reverse null, or whether you're looking for perfectly linear at the crossover point. Anyway, you can play with that delay just like you talked about. And I found both methods to work just fine. I got good results with both. But yeah, if you're using DSP, you've got more options for sure. More flexibility.
Yeah. I made a video a while back. It was one of my first videos. And I don't know if I titled it wrong or if I just ticked off the wrong people. It was about active crossovers. You guys are laughing like you've seen the video. It's got like 300 thumbs down or something. And every comment is somebody getting on there and saying active crossovers are way better. And I actually kind of agree. That wasn't the point of the video. So if anybody goes on my channel and looks at that, I'm big on active crossovers, but they take as much knowledge, and that was the point of the video. So like getting these measurements, when we're talking about these measurements, it applies to both, and you still have to understand what you're doing with the speakers and everything else. So a lot of people, I just say this because I brought up active crossovers, and I don't want people to think active crossovers are some kind of magic bullet where you just plug in all the wires, you start fiddling, and then boom, you've got this deluxe speaker. Yeah, it's not like that.
No, actually, I've talked about this numerous times on my channel too, because I do believe that there is this misconception that active is easier. Just in general, like active crossovers are easier. Just start active, just do active. And I would disagree with that. I think active crossovers are just as complex. However, when you get the basics down, you can actually do, you can probably tune out an active crossover pretty quickly.
Hey, Nick, are the comments coming up for
Oh.
everybody or just us?
I apologize. No,
Sorry, I wasn't reading them.
Because I just saw somebody saying awfully quiet in here, which kind of is today actually, but yeah.
Yes.
So this is one thing that I like about the new Omni mic software. This is something that Rue can do as well, and this is one of those things I think most people. Yes, you guys can always ask questions. One of the things that you can do in Rue and the new Omni mic software is determine where you want to start your sweep from. This is extremely important if you're going to be doing something like a planar tweeter or something. Okay. Now you can also use a cap or capacitor to protect that tweeter. Most of the time, actually, I'll say I don't worry about that typically on most of my other, like a compression driver. I definitely don't worry about it on a typical tweeter, like a fabric dome tweeter. I don't worry about that on, although I'm not giving it a lot of power either way. But if you're on something else, yeah, you need to either limit the range in which you're taking the sweep and or protect it with a capacitor.
When I'm doing measurements or implementing an active crossover speaker,
Right.
I always protect it with a large cap because of DC pop. So what I don't want to do is accidentally turn on an amplifier wrong or something and get a big pop and harm that tweeter. So I agree with that commenter. I missed who that was, but thank you for that. I think tweeters can handle a lot more abuse than people think. People treat them like little delicate flowers, and they're not. But
get my little delicate flower.
But yeah, I will in like an active speaker. I'll just put like a 50 microfarad on there or something when I'm measuring it, and when I'm implementing it, just to give it that DC protection.
It's a good idea. I'm guilty of never having done this myself. Many crossovers and never putting a cap on them because we didn't have the comments up at first. Just I want to say hey to anybody that we missed, but Social Sound Club says, hey guys, check this guy out. He's got some really cool speaker design videos. I believe he's a sound engineer. He's got a really unique perspective. I really enjoyed watching some of his builds. Check him out.
Nice.
You know all the other channels.
I live on YouTube. I live on YouTube.
I'm so out of touch. I apologize to all the people that I don't know. I'm out of touch these past few years. So I'm sure you all do great work and good channels.
So I wanted to just say this. Edelson said, hey, big up Toyd. His videos got me into tinkering with hi-fi in general. And I just want to say, that's always been my goal, and hopefully the goals of all the other people. Our goal is never to be necessarily the smartest people in the world. We want to learn from each other. Like, I want to learn from Ryan. I want to learn from Cameron. I want to learn from you guys. If you guys know something I don't know, I think that's great. I think that's good. We should all learn from each other. But the biggest thing is hopefully getting people excited about doing this. And right now, like, the biggest thing is measuring correctly, so that way when you do get something done, it can blow your mind and other people's minds.
Yeah, that's the best part. Other people showing other people. They're usually not impressed, but you get 1 out of 100 that smiles.
Speaking of this, I had some friends that I used to know from, it's actually my parents' friends. They came over to our house. They were visiting my parents. Came over to my house. They listened to my theater for the first time. And I played the beginning scene of Underwater, which is a great scene, by the way, to demo. Anyone that has ever seen it, starts about like 6 minutes in, and the whole place just starts exploding, and like water's running in, and they're running down the hallways yelling. It's great. And they're like, holy cow. Like, you never go to the theater, do you? Like,
nope.
Yeah, people listen to their TV speakers nowadays or sound bars, and it's not the same. Can we answer Keith Jones? I think this is somewhat related to speaker measurements, and it's a great thing to talk about as far as designing speakers, because we all really need to tackle this question. The bottom of the tweeter, I think he's referring to, the low frequency limitations of a tweeter.
Where should you cross it over?
Yeah.
Yeah.
Keith, as I just mentioned, tweeters are not delicate flowers. They're also cheap compared to most of the speaker components. So abuse the heck out of them, please. I'm sick of people who dance around and cross these things an octave above FS, or whatever rule of thumb they have, and like, oh, you got to cross this 1.5-inch dome at 3,000 hertz, or
I was going to give a rule of a thumb, but I think I'm going to.
Yeah. I once crossed over. I kid you not. I crossed over a 1-inch compression driver, just above the FS, like 2,000 hertz or something, and I put it in pro audio setting. It was a church, and I was able to see it live for over a decade. And it had no problem. Oh, and it was a first order capacitor.
Oh,
it was a capacitor and L pad. That's it.
Yeah.
That's it.
And it survived for over 10 years, no problem. I gave the church a spare because I was like, you're gonna need this.
Yeah.
Let me give some rules of thumb for real though, because I think
go ahead.
there are some good rules of thumbs, but we should clarify why they say rules of thumb. So one rule of thumb is to look at the FS, double it. So for example, if the FS is 700 hertz, then cross it over by 1400 hertz. Why do they say that? It's a rule of thumb. Rules are meant to be broken, right? So, but the reason why they say that is because they assume you're going to be using a second order on a tweeter, and second order might be the right answer. Also, though, we got to take into things into account. One, are we going third order or fourth order? Third order allows us to cross over even later. Fourth order can allow us to cross even later. And if you're going active, you could cross over even later, maybe. There's other things that we're going to talk about in a second. But another thing to think about is how good is this tweeter we're looking at? Are we talking about a compression driver that we're giving 10 watts to that can take 150 watts? That makes a big difference, right? Like if we're using a compression driver in a home theater setting, we can usually get away with a lot more than what we would be if we were going to be using it in an actual PA style environment. Same with if it has a really nice motor structure and it has a high. I think that's where a lot of people get confused, because they'll look at a tweeter and they'll say, look, I want to be able to play my system at 100 watts, but the tweeter says it's only 10 watts. I can't use that tweeter. I need to find a 100-watt tweeter. And that's just not understanding how the crossover works properly. And
how music power is. A lot of the power is down in the lower frequencies.
Yeah.
The high frequencies rarely see more than 1 watt.
Yeah. You're getting pretty loud on a tweeter with a few watts. Yeah. I'm doing a compression driver right now, and I don't want to say where I'm crossing it over, but just a couple 100 hertz above the FS with third order filters, and distortion is totally fine.
There's two things that I would like to look at myself. If I'm going to cross over it lower, well, actually, if I'm going to cross it over anyway, it doesn't really matter. Distortion, I like to look at what's going on, especially third order. We talked about third order being really important. The other thing that I'd like to look at too is I would like to do a. I lost my train of thought. Thank you, waterfall, and find out if there's any areas in which the tweeters has extra resonance where I'm like, I really don't know if I want it to play that frequency anyway. Now, any of those are probably going to be two graphs that I'm going to be looking at to help determine it. But yeah, like
I agree. I think in terms of measurements, distortion is a good metric. Maybe compression if you want to risk blowing up your tweeter. Generally, I get a lot of just looking at what the tweeter is. How big is the diaphragm? That's a big one for me. What is the quality of the tweeter? Who's manufacturing it? What's the diaphragm material? How is it being horn loaded? Is it very sensitive? If it has a lot of efficiency or sensitivity, which are different things, by the way, then you can probably
get. You are right, but I hate when people say that.
sorry, I said that.
No, you're right.
If it's very efficient, then you're going to be cutting it down with L-pad maybe, and so you're going to get away with a lower crossover. I've had compression drivers that are like 2-inch diaphragm, 1-inch exit. Well, a 2-inch mid, like that's a chunky diaphragm. You can cross that thing low, even though it's a 1-inch exit. So I get a lot out of knowing what to do with it just by what is it, as well as the measurements.
You talked
Yeah.
a couple weeks ago, actually. What software did you describe to model the excursion of a tweeter? Was that Visuix CAD?
He's
Myself?
talking to you, Ryan. Yeah, he's
Yeah,
talking to you.
Ryan.
I I probably did that in Sound Easy. Sound
Sound easy.
Easy,
Maybe that was what it was.
yeah, Sound Easy. You can do that, I believe.
Yeah.
If you have enough information about the tweeter, you should be able to. Yeah. I did talk about that, didn't I? Because you can map different crossovers and see just what's happening with your tweeter and the excursion profile. So I mean, really, that tells you a lot, despite what the measurements say. Um, yeah.
Just in case you guys were concerned.
You,
There, so the new OmniMic software does that as well. Here is a great question, and I really want to hear you guys' answers. I have an answer to this, but I'm curious. Where can I learn this stuff if I want to get into it myself? Speaker design, etc. And I'm going to tell you why I started my channel after I let these guys answer.
subscribe to my channel. You'll learn everything you need to know.
Hey, there's truth. There is truth. Like YouTube has become a great resource for learning things like this, I think.
Yeah, it's almost a
Honestly.
cliche at this point. Yeah, I mean, you can really learn anything you want to on YouTube if you're willing to put in the time and energy into actually learning it. A lot of content these days is so entertaining that it's easy to just turn your mind off and listen to somebody blabber for 10 minutes. But if you're willing to pay attention, take some notes. There's so many how-tos. Both of you guys' videos have taught me so much over the last several years. So
Yeah, I think that's a good point. I mean, I didn't learn on YouTube. No one was doing this on YouTube. I learned a lot by trial and error early on. Honestly, I learned a lot in Physics 101. It's
I
a
believe
crazy
that.
thing, but I took Physics 101 in university, and there was a lot covering waves, whether it was light or sound, and I learned a lot about waves. And yeah, and I was like into car audio and stuff as a kid, and but honestly, if I was starting over, I'd be looking at a lot of YouTube content.
So I'm going to tell you why I started my channel because I've mentioned this before. First of all, my channel was an accident at first. It was an absolute accident at first. Someone had asked on a forum, I think it was AVS forum actually. They'd asked how you did the overnight sensation crossover. Like, how did you take it from that diagram and actually like, what is this showing me? How do I know where to solder what? And so I did some videos on it, and they were terrible. They were awful videos, but a lot of people watched them because there was a lot of people wondering the same question: how do I do this? And when I was on the forums, one of the things that I absolutely hated seeing, and hopefully it's changed a lot since then, was someone would ask the question, they get so excited, like, I'm going to build my first speaker. This is the driver I'm going to use. I'm going to use these drivers. I've got them picked out, etc. And the first response was always, just don't do it. Just buy a kit. And I hate that. I really hate that. I hate that response because there is something to be said to warn someone, be like, hey, you know what? Like, I think it's a great idea to get started. Maybe you can start with a kit. But if you want to go this route, here's some of the things that you're going to want to know and start with. A good book, Speaker Design Loud Cookbook. You know what I'm saying.
Loudspeaker Design Cookbook by Vance
Thank
Dickinson.
you. Loudspeaker Design Cookbook is a great one. I have it right there in my closet over there with the rest of some of those. That's a great one to start with. But honestly, YouTube is really one of the ways for a lot of people to learn, because a lot of people now are visual learners. And so learning something like this on YouTube is a great way to do it. And that's why we do this. We do this because we don't want you to have to ask that question.
Yeah,
How do I do this?
I'll say if you're going to use 21st century stuff like forums and YouTube, that's great. Visual learning is really, I mean, it's hard to compete with. But I've got a copy of the cookbook, and I've probably read it 3 times. It's essentially a textbook. It's not a book that walks you through, speaker design is so complex you really can't. And Vance Dickinson is not a short-winded person, and he uses for the fact that it's a textbook, he uses a ton of graphs to show you exactly what he means. He's got figures for each thing he explains. So if nothing else, get an old copy of it, because the newer one's a little expensive and it includes DSP and stuff like that. Find an old used copy and just keep it on hand, because there are so many types of questions you really can't and you don't want to ask a forum that you can find the answers to in that book, despite it being 20, 30, 40 years old now.
So Keith, I don't disagree with this. He says the typical reason people say to start with a kit is because they're easy. I agree with that. And I don't necessarily think that that's necessarily bad advice to start with a kit. But the last thing I want to do is take someone that's really excited about designing their own speaker and tell them not to do it. Because if they're willing to put the time, like, that's how you kill a hobby. That's how you stop people from wanting to do this, is when people are not willing to take that extra step and be like, hey, if you're really interested in like learning, I don't know how many patrons I've had. I've had a lot of patrons that have become my patrons, and we talk back and forth, and I walk them through some of their own designs, and I go hand in hand with them to help them get to where they need to be to find a speaker, because they wanted to do it. Now, some of them aren't even my patrons anymore because they've got to the point now where they understand it. And it's great. I wish that more people would get like that, because I want to see this hobby grow. Like, I wish there were more people in this hobby, because I think it's a beautiful hobby.
Yeah, we need them. Keep building speakers, you guys.
All right, Ryan. Wait, I want to hear what Ryan has to what I just said. Ryan, what do you think about what I just said?
Yeah,
I've never talked to you about this, so.
No, I agree. Like, I'm probably guilty of saying start with a kit, and there is a lot of, as Keith said, there's a lot of good reason for that. But if someone feels confident, like if they're asking the question, and we'll try to get to it, like, how do I read a schematic? Then you're at the level where you should buy a kit and figure out how to read this schematic. Because and that's not to poop on somebody. If you're at that level, you need to start there and, do the woodworking part. Maybe you enjoy that. Handle some speaker drivers, handle some crossover components, and create something that you can go, wow, that's awesome. If you're starting from scratch and you're buying a measurement microphone and a bunch of parts and all this stuff, and it turns out like crap, because it probably will, then you're going to be really disappointed. But I agree. If you have some confidence, like, give it a whirl. I mean, I eventually did, and I love it. And,
the problem is, like, what we've kind of gotten across is that a lot of people that are going to want to learn, that's where they're going to have to start now, because there's not a lot of great places for them to learn.
Brian Juffs says open baffle is an easy first build. I would say this, Brian, real quick. I agree with you. Just don't expect much out of it at all. Like, just maybe don't expect much out of it. I believe to do an open baffle perfectly, or properly, I should say, never perfect, you need 4-way, active, very narrow baffle, a very expensive tweeter, and it's not going to be efficient. I don't have time to get into why, but if you want to do an open baffle properly, it's very difficult. So carry on.
We've had a couple questions. Looks like people are asking about reading crossover or reading schematics in general. Have either of you guys done? I think, Nick, you just described that one of your first videos was on how to read a schematic. Is that about right?
No, not how to. Well, kind of. Yeah. If you want to, I do have one that shows you how to do it now, how to take it. What I would tell you is, if you're doing this for the first time, and this is one of the things that I think most people should do, if you're getting a schematic that shows the drivers laid out, like it shows this is the mid-range, this is the tweeter, and here's all the components in between each one. So it shows here's all the components with tweeter, here are the components of mid-range. If I were doing that starting out fresh, I would say make 2 separate crossovers. One for the tweeter, one for the mid-range. That way it's easier for you to diagnose later if something's wrong. If something's wrong with the tweeter, you don't have to go through the whole crossover. You can be like, okay, what's wrong with these 5 components or 3 components or whatever. For me, and I say that in the video too. I do the video and I say, look, if this is your first time doing this, don't try to combine all the crossover parts. Do a separate tweeter, separate woofer.
Yeah, I should do a video on reading schematics. Once you understand them, they're very simple and straightforward most of the time. So once you get the hang of it, reading the schematic is a piece of cake. And like Nick said, actually, if you have to physically lay your parts out in the way it looks on the schematic, that's even one way to get around that. So I'll do a video on it.
So I've been talking to Vaughn. He asked me this question. By the way, he's got some really cool guitars. If you guys, I'm not a musician myself, but if you're into guitars, you should check him out. He does custom guitars. They're really cool. I checked them out. He says he's doing the Epic build, and the aluminum cone passive radiators are not in stock, but the paper ones are available. They're the exact same. They tune exactly the same. Go ahead and use the paper ones if you want. I only did the aluminum because I like the look better. But if you like the look of the paper, or in this case, they're not in stock.
So speaker measurements.
Yeah, we got off track.
But you know what? That's the great thing about this show is that if people
Sure,
have questions like this, man, that's what we're here for, right? That's what we just said. So,
Yeah,
Totally.
absolutely. So I think we left off talking about measuring an assembled speaker. Do we want to continue on that line of thinking? Is there anything we didn't cover?
Let's do subwoofer because we haven't talked about subwoofer measurements. I think we did a pretty decent job with at least a 2-way. We can always go back to a 3 or 4-way later. But what about subwoofer? How do you guys measure subwoofers?
Depends on the sub. If it's a sealed sub, near field, and you pretty much have it. I mean, you could do a ground plane, but that's a lot of work.
Yeah.
So so sealed subwoofer, basically the easiest subwoofer to build. Near field measurement means you put the microphone very, very close to the cone of the subwoofer. You run your measurement. You have pretty much an anechoic frequency response.
This is with no gating turned on, right?
Yeah, this is a totally raw measurement because that microphone diaphragm is so close to the cone, the room reflections are swamped out. And so you get basically an anechoic response of your subwoofer. And then you can measure from your listening position, you can overlay the two and you can see what the room is doing to that response. I pretty much only build sealed subwoofers, and not only, I build lots of ported too, but that's what I like.
I don't know what to believe anymore.
I keep changing my mind. And that's what I do. I measure a near field, and then I measure the same subwoofer in the room, and I start playing with my DSP and everything else.
Yeah.
Sealed is the easiest for sure.
that is the easiest one to do, is measure right there at the cone. You're good to go. And like what Ryan said, all we're trying to do is get rid of room reflections. Now, this also depends if you're trying to measure the room or not. So if, for example, you have a subwoofer and you're trying to measure what it does in your room, then you'd put that wherever you're trying, like your main seating position. And then you would run it without gating again because you want to know what it's doing. And then you would measure it at that seated position. Yeah. So you can do either.
Real quick, I always go passive. I rarely use a plate amp, and then I get a pro amplifier.
Yeah, that's a great question. Plate amplifiers, for a long time, coming from the consumer world, you're so used to seeing a subwoofer with a plate amplifier on the back of it. In my mind, when I got into speaker building, coming from the car audio world, I assumed that all home subwoofers that people built had a plate amplifier, and some of them do, and they make really good plate amplifiers. But man, they're so expensive watt for dollar compared to a professional application amplifier, something like a Crown, anything of that nature. And there's so many leaking issues and durability issues with plate amplifiers that if you have the means and the wife isn't going to kill you for having a Crown amplifier somewhere in the living room, I would definitely go that route.
I would go that route for multiple ways. One, it's much easier to run speaker wire than it is to run a long RCA. Granted, you can make your own RCA, but just in general. But I have no problem running a plate amplifier depending on the wattage, right? Like 250, 500 watts, I'm okay. 250, really. I really don't mind. They're affordable. There's nothing wrong with them. They're usually designed for that. So like when I built the ISO 100, I used a 250 watt Dayton plate amplifier. It's pretty inexpensive. It's probably gonna be cheaper than any crown amplifier going to be buying, and it was more than enough that it needed.
That's
But
true.
if I'm going bigger, 800 watt, 1000 watts, one of the other things you got to think about is cooling. So when you think about a crown amplifier, those things or Behringer or whatever PA amp, those things have active cooling in it, right? They have fans going on to keep it cool because you got a lot of heat in that. What you don't typically see is a 1000-watt plate amplifier with cooling on it. I'm not saying it doesn't. It has a radiator and all that, but not active cooling like you usually have on those other things. And I would rather have that cooling as well.
That's a big benefit. Yeah, my crown. I hear if you get close enough, you can hear the fans run, but it's not something that I think is ever going to disturb movie listening or anything like that. So,
have either of you guys owned a Behringer?
I have a Behringer iNuke.
Did you have it before the fan mod or after?
No, it still has the original fan in it.
Oh my gosh, that thing sounds like a helicopter taking off.
I'm gonna have to mod it for this new place, but I had it kind of like way off and it was fine. But yeah, in the new house, I'm gonna have to do something with it.
Yeah, I had the iNuke 6000, and that thing, I turned it on and I was like, what the heck, is there a helicopter going? I was like, it was in this small room. I was like, what the heck? I was like, I see why everyone does these fan mods now.
Just watch Black Hawk Down every time. You'll be all right.
Just that one scene.
Yeah.
I want to get back to measuring subwoofers to make sure nobody misunderstands. The near field works great for a sealed sub. It can also work for a ported sub, but there's a bit of a problem. You're only going to capture the output of the cone. Mm-hmm. And what you're going to see is you're going to see this cone do this, and then it's going to drop off and then come back up. And that's very useful information because that very pointed null is actually your port tuning. Mm-hmm. But that's not the output of the sub. Mm-hmm. So you could then do another near field in the port, but you don't know how they line up, okay, in terms of amplitude. Frequency-wise where they line up because that's a given. So you can overlay the two and you can see what the driver is doing and what the port is doing. But you don't really truly understand the total output of the subwoofer anechoically. So ported subwoofers, I always try to do those ground plane outside. And you have to be outside for this one. You're not doing this one in your living room. You need a lot of distance. Like I try to get 30, 50 feet, like your whole backyard. It's very frustrating, but that's the best way to do it.
Yeah, they're just so much more complicated because your port output isn't necessarily directly proportional to your cone output. So yeah, you need another method, and taking it outside for DIYers like us is just about the only option in doing a ground plane.
Yeah.
So and the other thing to think about is if you need to know port tuning and you want a really easy way to do it, take a DATS measurement, get your impedance measurement. This can be really helpful if you're trying to fine tune the port size, right? Like if you're like, do I need to lengthen the port a little? Do I need to shorten the port a little? Is it exactly where I thought it would be? You can take a quick impedance measurement and it's going to show you that port tuning. Now, what the impedance measurement will look like, it'll have one big hump and then it'll have a dip and then it'll have another big hump. That dip, that lowest point of that dip is where your tuning frequency is. So if it said 32 hertz, then 32 hertz would be your port tuning. If you wanted that, lower, then you would lengthen the tubes.
Yeah.
Your ports.
Absolutely.
Yeah. DATS V3 is an extremely powerful tool. You mentioned earlier on, you kind of alluded to this, but it also has a component measurement.
That's
mode.
A great point.
And my cheap self, I'm kind of like a buzzard. I scavenge a lot of parts off of old speakers, cheap stuff around the house. And so anyway, a lot of my prototyping stuff is just really obscure old electrolytic caps and stuff like that. If you want to know the value of an old coil that's not labeled, run it through your DATS. You get a really precise reading down to like the third decimal place or something like that. So, or if you've gotten cheap parts off the internet, AliExpress or something like that, and you want to validate the claim, if you want to make sure it's in the tolerance of whatever you modeled in your prototype, then DATS V3 is really useful for that too. So,
Can I answer Wime Kim's question?
Yeah, I was going to bring that up. So his question is, so what they're talking about is a reverse null, right? So if we have two speakers that we are already in phase, the tweeter and the woofer, then we can reverse the tweeter or the woofer. And with that reverse null, we should have a big dip, is what he's talking about, at the crossover point where the phase is. And he's saying, hey, is that always necessary?
It depends is the answer.
I
Well,
I would say Wime. I hope I'm pronouncing that right. In general, we want to see this. We want to see a reverse null. So yeah, if your speakers are in phase, you flip the polarity of one of the drivers, and you should get both drivers canceling out where they overlap. So basically, you have two drivers, and they're making sound kind of like that. And over that crossover, if they're out of phase, they should cancel out. Now, I just want to. The reason why his question caught my eye is because it's measurement related, but I think a lot of people miss the point on this. They either watch a YouTube video or they read a forum or something like that, and they think, okay, I got to get this deep reverse null. And so they'll get something that goes way down to 0, and they think, nailed it. I do not think that is as important as getting a wide null, because, well, and this gets complex because it depends how much overlap you have. But what you
and
want,
it does depend a little on the order of it too.
Yeah.
yeah, if you have a
There's a lot
really
of things.
steep crossover and they're doing that, then your null is not going to be wide. It can't be. But if you have a lot of overlap, Wime, try to get that null to cancel out over as much range
Can I
as
stop you
you can
just
get.
for a second?
Yep.
I'm pretty sure it's why me, Kim. I think it's like a play. I don't think it's why.
Yeah.
I'm pretty sure. But anyway,
Yeah.
go back. Talk.
Are
So
you
go
pretty
back to
sure, or
why.
are you 100% sure? Because now I'm 100% sure. But thanks.
I'm just trying to be nice to you.
Well,
I know.
so Ryan, include this in
No,
your. In,
finish what you wanted to say though.
No,
I'm sorry.
that's it. Yeah,
I
He-
couldn't
go ahead.
be saying whyme anymore. I'm like, man, I'm pretty like I'm
This
trying
guy's
to
an
be like,
idiot.
he says
he said
yes.
yes to why me, I think.
So he asked, regardless of whether it's second, third, or fourth order, and if you
Well,
look at the
he answered that, I think.
yeah, if you look at textbooks, they'll tell you this your reverse null should go this deep. And I guess the exception I mentioned is that it's not always going to be perfectly as deep as the textbook reverse null should be in theory, but you do want to make sure you have a deep and really consistent symmetrical reverse null at that crossover point. So
The thing is the whole reason I get upset about the deep null is because you give me any speaker that's designed that way. There are speakers that are like 90 degrees out of phase and they're going for sound power, blah, blah, blah. If you're going for a speaker that has a reverse null, I can take that microphone and sweep and sweep and sweep and just move that microphone around and I will get 0.
yeah,
I will get 0 eventually.
yeah, and like
But
an
you may-
inch.
But you will have potentially very little overlap.
Mm.
And the reason why we want a reverse null, just to get back to like, why does this even matter? Is because if you have a wide and deep, but who cares, reverse null.
Deep and wide.
Yeah, if it's deep and wide, that means when the drivers are in phase, not necessarily both are in positive polarity, but when they're in phase, that means both drivers on the listening axis are summing very close to 100%. They're totally in phase, which means you're getting the maximum output and you're getting, people talk about phase. I'm not sure how much that matters, but you're basically getting the best summation and the drivers are playing together the best.
And this should be a question as well. Do they need 100% phase?
No.
I'm not saying ideally. I'm just saying, do you?
Do you need them to be 100% in phase?
Yes. That's what I
No,
just asked.
because no. Okay. Again, you can take
And
that microphone.
I think this is important. Yeah.
Yeah, you can take that microphone and you will eventually find a spot where they are 100% in phase, right? Now, does it need to be 100% in phase on your listening axis? I mean, ideally, I guess, but I think it's really low priority. I just think you want to be close enough that your listening window, it's in there somewhere. You know what I
Yeah,
mean? Which it will be.
I agree.
So I think this is on topic. I want to answer this question, by the way. He said a little
That's
off
fine.
topic, but I assume you guys don't care for hi-fi. I'm assuming he means high fidelity. Talking about, oh, unless he means hi-fi. Maybe it's like why me hi-fi.
No.
Why hi-fi? Talking about commercial power amps and building your own stuff. I love hi-fi. I love commercial power amps. I have no problem with that. I just went to Axpona and listened to a bunch of different speakers. The thing is, if you're willing to put time and effort, and you're going to have to probably buy multiple components, you can get great results at a fraction of the cost of a hi-fi, like a crazy hi-fi system. You know, if you're talking $100,000 speaker sit up. You know, a hi-fi, you can save quite a lot of money, and I think that's one of the allures of hi-fi. I'm sorry, of DIY, is being able to build these yourself. To say, yeah, I can get the performance of this other speaker, but I didn't have to spend nearly as much, and I can make it look how I want it to fit inside my room.
Yeah, I think commercial like pro audio amps are perfectly satisfactory for subwoofers.
Mm-hmm.
I think they're even satisfactory for your main speakers. I think they get a lot of, crap for no reason. And I don't have $100,000 to spend on my hi-fi system. And I invite Edelson over to hear my system and be prepared to understand why we can build this stuff just as good. Yeah, it'll pound.
Party. We're
It'll
all
be a
doing a
party.
party at Ryan's house.
Sure, come on over. It'll be a
Everybody's
party.
invited.
And yeah, I'll
No, I think you're absolutely right. I mean, I don't know how many people have built speakers of mine that said, "Holy cow, I didn't expect this," especially at the price point that they were paying. Right, they were doing $500 speaker builds, and they're like,
yeah.
"Wow, this is amazing." And there's truth to that, right? And that's kind of always my thing. And we talked about this a little last week. How we talked about how, you know, the cheaper you go for a speaker, the harder it is to compete with DIY. But the more expensive you go, the easier it is to a large degree to compete.
Yeah.
Yeah. He says
as far as the same value.
Snake oil more so. So I guess he's referring to hi-fi. Yeah, am I comfortable saying we're all kind of objectivists? I'm not
Yeah.
against owning a Macintosh power amplifier. I kind of aspire to have that kind of money to throw around one day, or a nice set of commercially available speakers. But yeah, I think we're all mostly objectivists when it comes to all the cables and stuff like that for the most part. But I personally don't have any hard and fast rules on that. If you want to spend more money on things like that, go for it. But
one of my most popular videos is showing how to make hi-fi speaker wire, and it's literally just speaker wire with a jacket on it, you know, and
So
some
good.
speaker pants. I didn't expect it to go. It's funny because this is when Ryan was actually active in YouTube, and I said to him, I said, I didn't expect that video to do very good. And he's like, "Oh, I knew it. I was going to hit out of the park. I knew it." I was like, "Oh, well, I wish I knew that what you knew when I met."
I don't know. I don't do stuff like that. But yeah, when I saw that post, I was like, I still remember that, and it was years ago. I was like, oh, that's a great video. People are gonna love that.
Yeah.
Carlos, yes, Class D is gonna overtake AB. I mean,
It already is.
Yeah, it's just so efficient.
You know, the interesting thing, and I was just talking to someone at Axpona the other day. I'm not going to mention who, but they said they had heard Orchard Audio's amp for the first time. And I love Orchard Audio. By the way, you can buy a DIY kit from Orchard Audio if you want to. Now they're more expensive, but they do use a GANFET. And I was talking to him, and he said this is the first Class D amplifier that has won me over from Class AB. He's like, I would much rather have this than a Class AB, which was surprising to me to hear this specific person say that.
Yeah, they've got a really cool designer, the engineer that designs all that stuff. He really cares. I mean, he tests all his own gear. He's really he shows it to the public, stuff like that. I forget his name, but he sent
Leo.
I think it is Leo. Yeah, he sent me one of his DACs.
It is Leo.
Yeah, I love it. Nothing but good things to say about him.
You're talking about Orchard Audio, right?
Yeah.
Okay. I just want to. All right, guys. Well, we're out of time, so if you guys have more questions, ask them next week. Like we say, the only way we can guarantee a question asked is if you super chat us. That's just because it actually like stars it for us, so we know that we have to answer it. Otherwise, we get caught up in crazy things that we talk about. But before you go, each one of us has things that we're going to be putting out on our channel. So let's go ahead and tell you what we have going on. Ryan, do you have anything planned yet for your channel? I know that you're still kind of in the move and all that stuff.
Yeah, I've been saying for every podcast so far, and I still need a few podcasts before I can say I'm doing anything. I'm getting very close to having my computer area set up, which actually has an audio component to it. So I might do a short or something on that, but I'm still like a month away probably before I can really produce any content.
Well, no, we get it. We completely understand. What about you, DIY Hi-Fi? I got something really cool I'm excited about, but I want to hear what you have first.
I'm actually going to say the same thing I said the last couple episodes. This big high efficiency build's kicking my butt, but I'm almost done with it. Probably order crossover parts in the next day or two and have her out in another week or so.
Have you ever thought about doing a video of like this thing's kicking my butt and like talking about what's kicking your butt about it? Like that'd be kind of an interesting one. I'd be interested in that. You know,
I could probably rant about the woes of speaker building, especially heavy speakers. I mean, it's so easy to injure yourself moving these things around.
You could name it, "This speaker's kicking my butt." Here's why.
Yeah, that's a good video.
I would click on that. I'd be like, "Whoa."
I think honestly, in the meantime, I may kind of quasi commit to this right now. I think I might do a simple video on reading a crossover schematic and solder up a couple like really complex and really simple crossovers and walk you through the differences. I think that could be helpful.
We can never have enough of that, or even just showing how to, do a design or whatever. Those are always really good videos, I think, for the masses.
Yeah.
What about you? I have a build coming up, and I'm super excited about it. And it's a little different than what's usually on my channel, but I think it's pretty exciting. I'm building a virtual pinball machine.
Ooh. Pinball
with a custom audio system, so it will have custom audio. Don't worry about that. But yeah,
with a 24-inch subwoofer on the back.
So I had this company send me this little mini computer. It's like this big. It's tiny. It fits in the palm of your hand. It's the size like a mini Mac, and they sell for like $400 or $500. This is a crazy thing. And I'm like, I don't think it's going to be very good. This thing is amazing. I'm like playing like all my games at 1080p. I was surprised. Now, not in like the highest settings or anything, but I was surprised at how good it is. And so I was like, well, I wonder if this would work with virtual pinball. And so I started hooking up monitors. I have 2 TVs just sitting around them. Like, I got to do something with these. And I have space for a pinball machine. So I was like, well, let's see. And it worked. I was like, I cannot believe this is working. It's actually doing the playfield at 4K and the back glass at 1080p. And it's playing it really well. So I decided to go forth with the build. I'm designing it on that computer over there. I'm going to be doing all the CNC work on it, building it. And I think it's going to be pretty cool.
That's really cool. That'll be exciting.
And I have some projector videos coming out for anyone that's excited about projectors.
Can I just make a plug on like a 5-year-old video? I did a video series. I think it's called Life S5. That was the name of the speaker I chose.
I remember that one.
Yeah, it's a little desktop speaker. And I was really proud of the video series. It's like 4 or 5 videos. And in there, I build the speaker. I measure the drivers. I upload the actual measurements to Dropbox or something, which you should still be able to download. And I even had viewers submit crossovers, and then I wired them up, measured them to show how they turned out. And you kind of need to watch all 4 or 5 videos. I don't know, it's probably close to an hour altogether, but it really was, how to measure a speaker, design the crossover, and measure it to see what results you get. The whole thing just went through it all. So if someone's truly interested in kind of a start to finish, how do you measure a speaker? How do you get the measurements you need to design and then measure it to see that it worked? That video series might be helpful. And one day I hope to do another one kind of like that.
Cool.
That's a great one. And I like that too, because other people sent you crossovers and then you tried them, which was cool. And then you also walked through why you thought they might have done what they did and why.
Yeah, that's right. Yeah.
Edelson Rodriguez said, "Hey, nice going. I subscribe to both DIY Hi-Fi and Impulse Audio." And guys, that's the thing.
Thank you.
Go ahead. Yeah, please subscribe to everyone. That's the only way we're going to build this community and let people know that this is an important community to go behind. So definitely make these channels grow. All the channels.
Every day, Jay asks the PSS 555. That is the cheap. That is the cheap Dayton 21-inch. He asks what size recommended for sealed. I would go like 2.5 cubic feet, maybe 3 cubic feet at the most, and use DSP if you can. But if you just go sealed on a sub that big, you're going to be really happy with the response.
Yeah, typically, I'll just say this real quick. Typically on a 21-inch sub, I would like to see the F3 in the mid 30s, typically for like my room. I know I did a video on this. It's called Why Don't We See More Large Sealed Subwoofers or something to that extent. And I show you in WinISD how to get an idea of what your response will be with room gain. So I show you how to basically model room gain into whatever the response is that you have in WinISD. WinISD, by the way, is a free program.
That's a very important video. I didn't catch that. Like I said, I haven't been staying up to date, but people should watch that. Room gain is so magical. People dismiss sealed subs because they have an early roll off, but yeah,
you get the room gain.
Yeah. I'm going to tell my wife this. He said this is the best hour I spent on YouTube this week.
Thank you.
I mean, like, Sarah, you need to watch this week's. It's the best hour you'll spend on YouTube all week.
That's very generous.
All right, guys. We'll see you later. Thanks again. Remember,